All right, good afternoon, good evening, good morning, ladies and gentlemen. Welcome to a series of online lessons. Today, we will be looking at a very interesting concept or topic in mathematics. But before we go to that topic, I would just like us to identify this paper that is on the screen here. What is this paper? Okay, let me just zoom it in. Comment in the comment section what this paper is, its name, what it is used for, and why it is used. Okay. All right. So for those that do not know, this paper is what we call a graph paper. All right. Now, a graph paper is very interesting because it helps us accurately represent information. Okay, it's a paper that helps us represent information accurately. It helps us represent diagrams accurately, and so on and so forth. So basically, why it helps us represent information accurately is because of these big boxes that are here. Have you seen denoted by the solid lines here? And these small boxes inside here. Okay, so because going up and going in this direction, the boxes are of the same size, it will help us accurately measure something or accurately represent something as there is an even space between the boxes. Okay, so but what you should know about graph papers is that the distance from this solid line to another solid line, this is 2 centimeters. 2 centimeters. And in between these solid lines, we have 10 of these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in between this, that is 10. And if we divide this into, if we divide it into half, that is 1, 2, 3, 4, 5. Halfway here, from this point to that point, that is 1 centimeters, and from that point to that point, that will also be 1 centimeters, so that it makes up the 2 centimeters. Okay, let me just zoom in so that you can see properly. Then yeah, so that's basically it. Okay, so now when you're told to represent, suppose you're told to represent 1 unit to represent 2 centimeters, because you usually hear this if you are told to say 1 unit to represent 1 unit to represent 2 centimeters, meaning that you should count in ones. So from here, that would be your 0, then 1 unit to represent 2 centimeters. 2 centimeters is from this solid block to the other solid block. So from 0, that will be another 1. So 1, so that will be 2, then 3, and so on and so forth. So they'll ask you, so this is what we call the x-axis. Okay, just put it up. Then same applies on this direction. That is what we call the y-axis. Okay, so now you'll be taught the same thing. Maybe you are taught, let's do this. Maybe you're taught 3 units, meaning in threes, to represent 1 centimeter. So count in threes, but after every 1 centimeter. So we know that 1 centimeter is from halfway to of this box, so it is somewhere there. So that will be your 0, 3, 3 plus 3, that will be your 6 there. Then halfway again, that will be your 9. Halfway, that will be your 12, and so on and so forth. So that is, same applies here. Maybe they told you to represent in the x-axis. you do that. Then same applies if you're taught to represent maybe 2 units to represent 1 centimeter in y-axis. Again, you do the same thing. So in y-axis, this is the y-axis. So maybe you count from there. So you only have 1 0, you put it there, 0. That is from there, that is halfway here. That would be 2 units. Up to there, that would be 4, and so on and so forth. So that's basically how you interpret information, or how you use the graph paper to interpret information. Now, in today's lesson, we will be looking at a very interesting topic, and we'll be using the graph paper. Okay. Now, let's switch to the lesson. All right, so we will be looking at scatter plots. Okay, what are scatter plots? So basically, by the end of this lesson, you should be able to understand what a scatter plot is. So you should be able to give me the definition of a scatter plot. Then secondly, you should know how to construct scatter plot. Okay, you should know how to construct a scatter plot. Now, for us to construct a scatter plot, we'll need some data. Okay, so this data that we're going to have, it should aim at finding the relationship between that data. Okay, so basically we're going to need data, and we need to have data in hopes to define the relationship between that data. Okay, so for instance, we can try to find the relationship between age and time to complete a task. Okay, so we might have we may want to find the relationship between age and the time it takes to complete a task. Now, for this, we'll need individuals' age, maybe those that are 10 years, those that are 15, those that are 13, those that are 16. Then we subject them to a task, to the same task, and see the time they take to finish that task. Maybe those that are 10, maybe an individual that is 10, it takes them maybe 2 seconds. So this is time in seconds. Maybe an individual that is 15, it takes them 5 seconds. So no need to put the seconds. Maybe an individual that is 13, it takes them 4 seconds. Maybe an individual that is 16, it takes them 7 seconds. Okay, now what we need to do is we need to plot this information on the graph paper. What are we going to need for us to plot the information on the graph paper? We will need to determine which one of these will be on the x-axis and which one of these will be on the y-axis. Okay, so we cannot just choose to say age will be on the x-axis, time will be on the y-axis. Now, for us to determine which one will be on the y-axis, we know that those that should be on the y-axis are independent variables. Okay, independent variables, meaning that we can change them easily. Okay, and those that will be on the y are what we call dependent variables. Okay, that is, they cannot be easily manipulated by the experimenter. So me as the experimenter we cannot easily manipulate. Okay. So now, between age and time, which one is easier for us to manipulate? Okay. Of course, age, we cannot change the age of someone. If someone is 10 years, they are 10 years. Okay. Time, we can change time because we know that maybe if we increase the distance they take to run from point A to point B, then they will take longer time. So we can manipulate time. So time, since time can easily be manipulated, this will be on the x-axis. Okay, age cannot be easily manipulated. This will be on the y-axis. So now, as a group, you will plot the points in pairs the way they are. So that is x, that is 2, then comma 10, then 15, or that is 5, comma 15, that is 4, comma 13, and that is 7, comma 16. So we are going to plot this on the graph paper using a scale of 4 centimeter to represent 4 centimeters to represent 1 unit. Okay, on both axes. Okay, no, on the x-axis, and 4 centimeters to represent 10 units on the y-axis. Okay, so in groups, let's try to plot these points and see what our results will be. So for the y-axis, so we're going to draw the x-axis. Now we need to look at the data set that we have. If we don't have any negative numbers, then we just use the upper half quadrant. So we are just going to draw a simple graph like that. Okay, so now we are using 4 centimeters to represent 1 unit. So this is 1, 2, 3, 4, 5. And on this chart, we're using how many centimeters? That is 4 centimeters to represent 10 units. So 4 centimeters to represent 10 units. So this is 10 and 20. Okay, now we need to plot the points. So the first point, that is 2, 10. So we look for 2 here, 10, it will be somewhere there. So we put a star there. Then the next point is 5, 15. Okay, so 5 is there, 15 will be halfway there. So 5, 15 will be somewhere there. So basically you're going to count from here, halfway, if this is 20 and this is 10, meaning halfway here, that is 15. Okay, 10, then 20. This is 5, 10, 15, 20. Then meaning that is 25 and so on and so forth. So you count like that, then the other points. So basically those, we continue for those, then we will put, then we have 4, 13. So we have 4, 13. So if this is 15, halfway there, that is 12.5, 13 will be somewhere there, 4, 13, be some sort of that point there. Then we have another one, 7,16. So 7 maybe somewhere there, 16, which will be way on top there. Then what we'll try to do is we will plot, or we'll write a line that fits most of the points. So we see that if we draw a line like this, it will fit most of the points, and that there is the outlier. So basically, this is what we are supposed to do. Then from there, we'll be able to determine the relationship between edge and the time it takes to complete a task.